JUnit is a habit, not an afterthought. Appendix D. Lab method naming conventions. Lab method naming conventions. Each method we are testing will have one or more corresponding unit tests. This is done so that the granularity of our unit testing is high for the purposes of readability and maintainability of unit testing code. There are several types of tests we run on a method, which are discussed in the next slides, with the naming convention we will use specified. There are several types of tests we will write for a method as needed, which are: test correctness of outcome for a common use case of or common use cases of the method. There could be one or more such tests, each testing one common use case with appropriate data. Test special, nullable, or corner cases, and special, null, or corner parameter values for a method, such as zero, null values, min and max values, or values otherwise considered special or corner cases for the method. Test exceptional condition or exceptional conditions for the method, such as the exceptions expected to be thrown given certain input. We can put all unit tests for a method either in a test class, or we can use the @nested annotation to group all unit tests for a method within an inner class for convenience and even further readability and maintainability, which is what we ended up doing for all our unit tests within the course. We are going to use Camel case notation in all cases. We will also separate descriptive part of the unit test method name from the generic part as clear from the above examples. So the structure is: the first part of the unit test method name is the name of the method we are testing. The second part of the unit test method name is the name of the type of case we are testing, of which there are 6 that we are using: common case, special case, nullable case, which is a type of special case, empty case for arrays and collections only, corner case, and exceptional case. So, except for the common case, you can see that special, nullable, empty, corner, and exceptionals are all special types of cases that we just choose to separate and further granularize. The further parts are the parameters we pass in. For primitive types, it is the name of the type expressed as a string name. For object types, it is the type of the object we pass in, or null. But for null, we will optionally forgo object types. It can be just null. Right. And finally, the last part of the unit test name is the return value of the method. For primitive types, it is the returned literal value of the type, expressed as a string name, or it can be the not a literal value, but it can be the int or float, etc. For object types, it is the type of the returned object we pass in, or null. The expected value is permitted but is optional. So of course you're lost at this point, but there will be examples later for you to catch up. There is no special allowance for a unit test method testing a method with the throws keyword in its signature, but you would be expected in addition to test for exceptional conditions in this case. If we need to provide several different tests having the same method name and same parameter list, we can add __ number at the end. Please note the 2 underscores. So examples begin. So we could have a name like this. If we have a unit test method called do, then we do underscore common, because we're testing a common case. We are passing an int, and we are passing a second int, and it returns a void. And __ 2 just says that we've overloaded it, this method. Because we needed to test 2 types of values for ints, for example. So what would such a unit test name test? It would test something like public void do int i2, or public void do int i2 throws exception, for example. So that's the naming convention we're going to utilize. And let's take a look at some more. For some method called public int do integer in, we might have the following test method names. And can you guess the parameter types and the return types given the examples in the previous slide, and let's take a look at what we're going to have. So for common cases, we're going to have void do underscore common underscore int underscore int. Void do underscore common underscore int underscore int underscore underscore 1, where the first int is the parameter we're passing in, the second int is the return value. Overloaded unit test, for example, could be void do underscore common int 10 underscore int 0. In this case, we are saying we are passing an int value of 10 and we should be getting an int value of 0. I'm sorry, overloaded unit test means that it applies to the void do underscore common underscore int underscore underscore 1. So for void do underscore common underscore int 10 underscore int 0, it means that common unit tests with both parameter types and values specified and with return type and value specified are possible. It provides for best clarity, but it is optional. For example, we could do void do underscore common underscore integer object underscore int. And in this case, we're passing in an integer wrapper object and we're getting an int primitive in return. Void do underscore common underscore int 10 underscore int. In this case, it is okay to provide the value of the parameter after the type of the parameter, but it is optional and we're providing it for the parameter we're passing in, but not providing it for the return value. We're just providing the type of the return value. So there is some flexibility. Another one is void do underscore common underscore int minus 10 underscore int. In this case, we're basically specifying we're testing a common case of the do method. We are passing in a parameter with the value of minus 10 and we're getting a integer in return, and we're not specifying the value of the integer, but we could. So that's for the common cases, some examples, and special cases. Let's do special cases. Void do underscore special underscore int 0 underscore int. So it is okay to provide the value of the parameter of the type after the type of the parameter, but it is optional. However, for special cases, you must provide it for clarity. In this case, because we are testing a special case, we must provide the value of the parameter, which is int 0. All right, and we don't have to do it for the return value. Let's go on. Some special cases, well, of which we saw the first one on the previous slide. Void do underscore special underscore int 0 underscore int. We just saw it. So that duplicates the data in the end of the previous slide. So let's just read it. It is okay to provide the value of the parameter after the type of the parameter, but it is optional. However, for special cases, you must provide it for clarity. Let's check for some nullable cases. Nullable cases is just some special case of a special case. We can do void do underscore nullable underscore null underscore int. Passing null for integer here. No need to specify type when doing so. So we don't have to write integer null. We could do it if we wanted to, but we don't have to. We can just say null. Void do underscore nullable underscore integer object null underscore int. We can also do that. We can say integer object of value null we're passing in, and we're getting a primitive integer in return. So some flexibility in how we can do that. Passing null for integer, no need to specify type when doing so, but it is okay to do so as well. An alternative notation, just so that you're getting the common idea of what we're doing. There is some flexibility in how we're specifying what we're passing in, what we're getting back, but so that you understand the general notation. This is very important. Empty cases, it's a special type of a special case. The empty case pertains to arrays or collections only. So if we had a method such as public int do int array ints, we could test it like this: void do underscore empty underscore int array underscore int, or void do, and we could overload it as void do underscore empty underscore int array underscore int underscore underscore 1. If for whatever reason we wanted to test several different types of values, we could do void do underscore empty underscore integer object array underscore int if we had an array of wrapper objects, for example, not an array of and not just an array of primitive ints. So for an empty array of integer wrapper objects, we would do that. For some examples of corner cases, max, min, etc. Would be void do underscore corner underscore int max underscore int. We're passing a max integer in as a parameter. We're getting an integer in return. So this is a corner case with int max value. For corner cases, the type's value is a must, because otherwise we just won't know what we're doing. So max or min here. For example, void do underscore corner underscore int min underscore int. Corner case with int min value. For corner cases, the type's value is a must, so it just basically repeats what I said in the previous example. Here we could do void do underscore corner underscore integer object max underscore int. Here we're passing, in fact, a integer wrapper object and max value at that. For corner cases, the type's value is a must. Again, we reiterate. And last but not least, void do underscore corner underscore integer object min underscore int. We're passing a wrapper integer object in, the minimal value of the integer wrapped in an integer object, and we're returning a primitive integer back. So, and again, corner case with integer object min value is present. For corner cases, the type's value is a must. And exceptional cases, we have some examples. Let's do, for example, void do underscore exceptional underscore int underscore runtime exception. Basically, we're testing an exceptional case where we're putting an int as a parameter, and we're expecting a runtime exception or a descendant of runtime exception to be thrown. Right, we are omitting the return type because in this case we don't expect any return type. We expect to be getting a runtime exception. Void do underscore exceptional int to underscore runtime exception. Here we are just basically specifying a slightly alternative notation. We're saying we're passing in a parameter of type integer, of type int, primitive, and of value 2, and we are expecting to get back a runtime exception. Next is void do underscore exceptional underscore int 2 underscore business rule exception. For example, we are passing a primitive integer of value 2 in, and we're expecting a business rule exception. And for all exceptional cases, we don't provide the return type at the end because it's not needed. Well, what if we have some totally special case? For example, for parameterized tests, we can specify them as follows. Add parameterized do underscore common underscore int underscore int. And within the parentheses, we would have some sort of obviously at parameterized test, it should be here, and within the parentheses we should have some kind of parameter, of course. So we're passing in a parameter and we're getting back a integer. That's what we're saying. Add parameterized test do underscore common underscore double object underscore int, and here we would have a parameter within the parentheses that I failed to include. So we're passing a wrapper object of double, and we're getting an integer in return. If we use the @nested annotation and we are testing an overloaded method with the same number of parameters, we could use the name of the class with the addition of __1, first overload, or __2, second overload, and so on. For example, if we are doing @nested annotation, @nested inner class to test the method do, which takes an integer, we would do just @nested class do, and to test its overloaded method, for example, do long, for example, we would do @nested class do __1 or __2, etc. So that's the rule of how we overload, of how we name @nested classes, which we use to test overloaded methods within our code base. So optionally, as you saw before, you can append the value of the primitive type you will be using to the primitive type name, and the return value as well, as in do _special _int 10 _int 0, etc. But we saw that before. So that's just a reminder that we can do that. It didn't have to be this way. It could be do _special _int _int, but we could do _special _int 10 _int 0. And for some of the special cases, the value of the parameters we're passing in is required, but the return value is not required, although it's optional. Alright, for non-integral values, we need to underscore the point. So do _special _float 10 _01. So we're underscoring 0, we're basically passing in a value of a float, which is equal to 10.01. So we're replacing the floats dot with an underscore. If we need to use the equivalent wrapper type instead of its corresponding primitive type, we will do it like this. We saw it before, but let's reiterate. Do _special _float object _int 0, for example. So we're passing a float wrapper object in, and we should be getting an integer of type 0. In order to do arrays properly for wrapper objects, we would do them as follows. Do _special _float array _int. That's for an array of primitive floats. Do _special _float object array _int. That's for an array of float wrapper objects. So these are just some examples, some rules of how we would structure our unit test names. It is very important for us to keep to this naming convention because it will give us the necessary discipline and readability to put together a great batch of unit tests for our library. In general, it is a must to keep some form of consistent naming convention, not only for easier understanding, but in case we want to parse unit test method names for our testing output, to include this name in the result of running our unit tests, which we have such options within the runtime. So good luck. I understand there's been quite a mouthful here, so you might want to take a look at the PDF file for this particular appendix to get your head wrapped around the rules for unit test naming that we're using. They are complex. They may not lend themselves well to understanding or parsing via the audio modality. You may need to take a look at the PDF and to reread it maybe a couple of times until you get into the habit of understanding it. And this is a good system for unit test naming to take into your own software engineer testing practice, by the way. So good luck again. Please seek out the PDF, take a look at it once or twice if needed. And there are a couple more appendices that are going to follow that I encourage you to take a look.